How Earth is created. The formation of Earth is a complex and fascinating process that occurred over billions of years through a series of stages. The most widely accepted theory explaining Earth's formation is known as the nebular hypothesis, which outlines the formation of the solar system as a whole. Here's a simplified overview of how Earth is thought to have formed. Nebula Formation. About 4.6 billion years ago, a massive cloud of gas and dust, called a nebula, began to collapse under its own gravity. This collapse was likely triggered by a nearby supernova explosion or some other disturbance. As the nebula contracted, it started to spin, forming a rotating disk of material. Protoplanetary Disk Formation. The spinning disk of material in the nebula is known as a protoplanetary disk. This disk contained a wide range of elements and compounds, including hydrogen, helium, water, methane, ammonia, and various metals. Accretion. Within the protoplanetary disk, solid particles began to collide and stick together due to their mutual gravitational attraction. Over time, these particles grew in size and formed planetesimals, which were larger chunks of material. Planetesimal formation. Through further collisions and accretion, planetesimals continued to grow in size. Some planetesimals reached sizes where their gravitational attraction became strong enough to attract and capture nearby particles and gases. These bodies, now called protoplanets, were the building blocks of planets. Differentiation. As protoplanets grew larger, their interiors became hot and molten due to radioactive decay and the heat generated from the intense collisions. This led to a process called differentiation, where heavier elements sank to the core while lighter materials rose to the surface. This differentiation created distinct layers within the growing protoplanets. Planet formation. Over millions of years, the protoplanets continued to gather material from the surrounding protoplanetary disk, becoming even larger. Eventually, one of these protoplanets became Earth, while the others either merged to form other planets or were ejected from the solar system. Final accretion. Earth's growth continued as it swept up remaining planetesimals and smaller debris in its orbital path. Atmosphere formation. As Earth's surface cooled and solidified, water vapor in the atmosphere condensed, leading to the formation of oceans. The release of gases from volcanic activity and impacts also contributed to the formation of the early atmosphere. Continued differentiation. Earth's core continued to grow and differentiate, forming a solid inner core composed mainly of iron and a liquid outer core. This differentiation generated a magnetic field that helped shield the planet from solar winds and cosmic radiation. Continued evolution. Over billions of years, Earth's surface underwent significant changes due to geological processes such as plate tectonics, volcanic activity, erosion, and the impact of asteroids and comets. These processes shaped the continents, oceans, and overall topography of the planet. The formation of Earth was a lengthy and dynamic process that involved a combination of gravitational attraction, heat, pressure, and chemical reactions. It's worth noting that while the nebular hypothesis provides a general framework for understanding Earth's formation, ongoing scientific research continues to refine our understanding of the specific details and complexities involved in this process. Thanks for watching.